Okay, so now let's look at question B2. Okay, so this question is on chemical kinetics. Okay. All right, so we have been given, consider the reaction, this guy here, and we've been given this table with some values for these reactants, okay? So in the first experiment, we have this as a concentration of this guy, this as a concentration of this ion, and then we have this rate, okay? Second one, we have these concentrations and that rate. Third experiment, we have this concentration and that rate, okay? So the first question here is they're saying, determine the order with respect to each reactant and write the rate law, okay? So the rate law is given by K, and then you put your first reactant to the power, let me say N, and then the second reactant, let's name it B to the power, let's say M. Okay, so this here is what is known as the rate law, okay? So for us to write the rate law, it means we have to find these powers here. So those powers there are called the order of that reactant, okay? So if this first reactant is order 2, it means here where there's N, we put 2. If it's first order, we'll put 1, okay? Just like that. And then these are just the reactants, the constitution of the reactant. And then this one here, the K, is the rate constant, okay? So we are going to determine these two powers, this N and this M, because they are the orders, okay? We're going to determine this N and this M by using what we call the method of what? Initial rates, okay? So we've been given different rates here. So this one here is the rate 1, this one is the rate 2, this one is the rate what? 3. So we are going to use this information here to come up with the value of N and the value of what? M. So what are we going to do? Okay, we are going to be dividing the rate of one equation with the rate of the other equation, making sure that one of those concentration for the reactant is what? Is constant. So if, for example, I get rate experiment 1 and experiment 2, okay, we see that the concentration of the iodide ions here will be constant, and then this one will be changing, okay? So we can use that, and then we can also use experiment 1 and experiment 3, where we see that the concentration of this first ion here, okay, this guy and this guy will be constant, but here and there they will be what? Different. Okay, so let's get into the solving. Okay, so the first, to determine the order, okay, we are going to get experiment 1 and experiment 2. So we are going to say rate 1 divided by rate 2. Okay, so rate 1 is given by a constant, and then we have the first reactant there, which is S2O 8 2 minus. Okay, this would be to the power N because we do not know the N, and then multiplied by the iodide to the power what? M. So this here on top, okay, will be the rate law for the first experiment, okay, and then down here I'm going to write the rate law for this R2, so it will be K, and then we have the same thing. Here we have the same thing. So this is the power N, and then this here will be the power at M. So now let's get the values from the table. So what is the constitution of this on the first reaction? What is the constitution of this on the first reaction? And what is the rate on the first reaction? Here we see that the rate on the first reaction is just 1.25 times 10 to the power minus 3. Okay, this is going to be divided by the rate of 2. Okay, so the rate of 2 is going to be what? Okay, so I should first I should start with okay. Okay, I should start with the bigger number on top here. So let's write rate 2 on top and then rate 1 down. Okay, so this is rate 2 and then this is rate 1. So what is the rate of rate 2? It's going to be 2.5 multiplied by 10 to the power minus 3 is equals to K. Okay, what is the concentration of this guy on the second rate? It's just 0.5. Then to the power n, the concentration of the iodide, okay, on rate 2 is 0.25. And then we have the M. Then what is the rate 1? Rate 1 is 1.25 multiplied by 10 to the power minus 3 is equals to K. Okay. And then what is the concentration of this first ion on the first reaction? It's just 0.25. The power n. And then here it's still 0.25 M. So what do we see from this write-up that we have done here? We see that this one is going to cancel with this one. Okay, the K is going to cancel with this one. This 10 to the power minus 3, 10 to the power minus 3 is going to cancel. So we are remaining with 2.5 divided by 1.25, which will just be 2 is equals to. And then here we are remaining with 0.5 to the power n, and then here is 0.25 to the power n. So we see that we have the same power here. So we can factorize that power so that we have 0.5 divided by 0.25 and then to the power n. Okay, so this is going to be 2 is equals to. If you divide these guys in the brackets, you're going to get 2 to the power n. So what is the value of this n? Okay, so this here is just same as raised to the power 1. So it means our n just be what? 1. Okay, and now let's find the m. So for us to find the m, we're going to use the third rate divided by the first rate. Okay, so we are going to use this. So what was the third rate? So if you check your table, the third rate is this one. Then we are dividing it by that one. Okay, so the third rate there, we're going to say is 6.25 multiplied by 10 to the power minus 4 is equals to K. And then what is the concentration of the first ion on the third reaction? Okay, is 0.25, and then the second one is 0.125. So I'm going to write 0.25 to the power n, and then on the other one, I'm going to write 0.125 to the power m. So I'm going to divide this, okay? And then I'm also going to divide this by the rate 1. So what was our rate 1? Our rate 1 was 1.25 times 10 to the power minus 3. And then here, what was our rate 1? To be K. And then what was the first concentration? Was just 0.25 the power m. And then the concentration of the iodine was okay. The concentration of the iodide there was 0.25 as well. The power m. Okay, so from this we can try to cancel out okay, so let's try to cancel out. So we can cancel K, we can cancel K. This is 0.25 to the power n, 0.25 to the power n. We're going to cancel it. Okay, so we're remaining with this value here and this guy is there. Okay, we see that here we have the same power, so we can factorize the power. So on the other side, I will have 0.125 divided by 0.25 to the power m. And then here, what am I going to have? So if you punch these values into your calculator, what are you going to get? Okay. All right, so let me patch them. So I have that's 6.25 to the power 10 to the minus 4 divided by 1.25 to the power 10 minus 3. Okay, so I'm going to get 0.5 when I divide this. And then here, what do I get inside there? So this is going to be equals to, I have 0.125 divided by 0.25. I'm also getting a 0.5 to the power m. So it means this 0.25 is the same as to the power 1, right? So I can cancel 0.5, 0.5. I'm just going to get my m is equals to 1. Okay, so we found that both my n is 1 and my m is what? 1. So meaning we can write the rate rule. So we're going to say rate is equals to, okay, we have the k here, and then the first reactant there, okay, which is S2O8, and then 2 minus to the power 1, and then the iodide to the power 1 as well. So this one here will be our what? Rate law. Okay, so we've answered the first question. Then the second one, they're saying determine the value and the correct units for the rate constant. Okay, so now since we know the order of this first reactant and the order of the second reactant, we can choose any of these experiments to find the value of K. So how are we going to find the value of K? We're just going to divide both sides by this, even the other side of the rate by that, okay, to find the rate of this K. So we're going to say K is equals to rate divided by these concentrations here. Okay, so let's just plug in the values. So you choose any experiment that you want. Okay, so let me choose experiment 1. It means the rate is just 1.25 multiplied by 10 to the power minus 3. Then I'm dividing all this by the concentration of this multiplied by this. So that would be, what was the first concentration? To be 0.25 multiplied by 0.25. Okay, so this is going to be equals to 1.25 multiplied by 10 to the power minus 3 divided by, what is 0.25 multiplied by 0.25? So 0.25 multiplied by 0.25. Okay, so I'm getting 0.0625. So let's divide that with those. Okay, so when I divide this, I'm getting 0.02. Then the units, okay, it will be molar to the power minus 1 and second to the power minus 1. Okay, why? Because the overall unit, the overall order for this reaction. Okay, so this first reactant has 1, the second reactant has 1. So the overall order for this reaction is 2. So whenever the order of the reaction is 2, okay, it means the unit should be m to the power minus 1 s to the power minus 1. So this is the value of what? K. And then the second question, the last question, it means determine the rate if each species is 0.02 mole. Okay, so we're just going to say rate is equals to the value of K is 0.2 multiplied by 0.02 to the power 1 multiplied by 0.02 to the power 1. Okay, so when we multiply all these, we're going to get 8 0.0 multiplied by 10 to the power minus 6. Okay, as my rate. Okay, so we're done with this question.